All right, we're going to talk today about interpreting a graph. Now, in this first one, our interpretation of the graph is going to be more than just, well, it looks like it's going up. All right, that's not enough. When you're talking about a graph, you need to be able to talk about its variables. What is going on between those variables? Any description should have some discussion, in this case, of time, volume, or about the air in the balloon. So as we start interpreting this graph, we need to keep in mind that the interpretation is going to be pertaining to those elements, not just, well, the line goes up, it stops a bit, but then it goes up again. Yeah, I mean, that's obvious. You can see that. We need to dive deeper in order to do this well. So our variables, as seen over here on the axes, are going to be time and volume. Okay, so now that we got that, we've also got our title, air in the balloon. The title tells us some important things about this. It's going to let us know a little bit more information about what this is all about. Now, with just time and volume, I really don't know much about this. All sorts of things have volume, and everything is passing through time. So for all we know, this is a graph of Mr. Shepard and his weight gain in college, okay, without knowing exactly what it is, and that's where the title comes in. It's telling us this is the air in a balloon. All right, so we found the variables. We found the title, and it lets us know that we're talking about air in a balloon. We know we're talking about time and volume, so over time the volume is either going to increase or decrease. And now we need to describe how these are related at various points. Now, you can describe a point in different ways. I'm going to start by just describing the different sections that I notice. So I'm going to give this section a name. I'm going to call it section A. Now, what's happening in section A is, the obvious thing is it's going up. More specifically, the volume is going up over time. But still, we're not getting at it. What is the main thing that's happening here? Well, it's air in a balloon. Now, if the volume is going up and we're talking about a balloon, that must mean they are blowing air into the balloon. And so that is what's happening. I'm relating it directly to the variables, but also to the title of this. I'm saying exactly what that section represents. Now, we've actually got a couple sections that are all that, blowing air into the balloon. Now, other than that, we've got these sections right here where it's not gaining in volume. It just kind of stopped. So what could that be? Well, I'll demonstrate. You gotta take a stop to take a breath as you're blowing up a balloon. All right, so this is where the person stopped to take a breath. All right, so I've described my different sections that I have so far. Where it's increasing, we're blowing air into the balloon. In those sections where it stays flat, we're not increasing in volume, but we're not losing any volume. The person was probably just taking a breath. Finally, something happened right there. It lost all of its volume pretty much instantly. So what happened to this poor balloon? Well, every child's nightmare. It popped. And somewhere out there, there is a 3-year-old crying, tears in his face, because his smiley face balloon has finally popped. But that's mathematics. Let's move on. Okay, so now we're going to talk about how, even without the numbers, we can figure out which graph is going with which thing. And this also, which graph is going with which table. This also is going to relate to when we want to create our own graphs. And maybe we're not using hard numbers, but we can still show kind of the shape of what would happen. So we've got this band allowed fans to download its new video from its website. The table shows the total number of downloads after 1, 2, 3, and even 4 days. We want to figure out which one of those graphs is going to match the table. Now, my beginning problem is, while I have numbers in the table, I do not have any numbers over here in these graphs. So I'm not going to be able to rely completely off of numbers to tell me which of those graphs match. So I need to do this off of some more basic observations. So one thing I noticed that as the days go on, the number of downloads is going up. Now, A, B, and C all show that this is going up. However, D shows a decrease. And so that can't be it. But A, B, and C are all showing increasing. So it has to be one of them. All right, well, then let's talk about what makes them different. All of them are increasing, but A keeps on increasing at a constant rate. Now, C is increasing, but the rate is slowing. So yes, it's still increasing, it's still going up, but it's going up at a slower and slower rate. B is also increasing, and the rate at which it's increasing is also increasing. It keeps going faster and faster. Now, of course, if I was this band, I'm really hoping that we look like B, because that means our fan base is growing and it keeps on growing faster and faster. That's the best way to get fans. Everyone's telling their friends. If everyone keeps telling their friends, then my fan base just explodes. But we need to figure out which one is it. Is it C, in which their fan base is basically coming to a limit and they're about as popular as they're ever going to be? Is it A, where their fan base keeps on increasing, but they're never going to really become popular before they die? Or is it they are slowly exploding and everyone loves them? So, in order to figure that out, let's look at how much it was increasing. Now, I'm not going to do some hard numbers here. I'm just going to take a look and approximate this. So it went from 340 to about 1,000. So after the first day, they gained 660 more downloads. Then from 1,000 to about 3,400. So then they went up by about 2,400 downloads. And then from 3,400 to 10,400. So they gained about 7,000 more downloads at that point. It looks to me like the rate, this is the rate, just how much it's going up each time, that the rate is actually increasing. So it must be B. Okay, now also bear in mind, while we can't always tell what some of those lines in the middle are, this is a specific number that we do know. Right there in the middle, that's going to be a 0. So keep that in mind as you look at some graphs. Does it make sense for a 0 to be there? If you're drawing your own graph, would it ever equal 0? If we're talking about the height of a human being from birth to death, well then they were never at 0 for their height. They didn't start at 0. They started somewhere. All right, so now we're going to talk about this rocket. So a model rocket rises quickly and then it slows to a stop as all of its fuel burns out. It begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. All right, so what sketch of a graph could represent the height of this rocket in flight? So we're just going over how to draw a general sketch of a graph. Now, first we need to identify the variables. Variables are going to be something that are changing in the story. The first and most obvious one is going to be the height of this rocket that is going up and down. Now, what is it going up and down over? Well, over time. All right, these are going to be my two variables. Next, I want to highlight the key phrases in the story that tell me about something is growing, something is going faster, it's going slower, it's rising. I want to find those differences that tell me what I'm going to be doing in my graph. Now, we see the first one very quickly. The rocket rises quickly, then it talks about slowing to a stop. And then it begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. All right, so we've just highlighted all of those key things that are talking about slowing, increasing, how fast, quickly, slowly. All right, so next we're just going to start drawing this graph. So I've got my axes. And now I need a title for the graph. I'm going to use something simple. Once again, your title should just tell the person who's going to look at the graph the bare minimum basics of what the graph is about. So this is all about rocket height. So I've got the height of my rocket over here, and then we've got over time. Now, I'm going to make a mistake first because I really want to emphasize an important point as you start drawing these graphs. Okay, now from the story, I know that it was rising quickly, and then it came to a stop, and then it started going down quickly, and then it slowly went down. Now, there is a problem with what I've done. And let's even go ahead and change it a little bit. Let's show that we actually did stop for a little bit. So, all right, there's our stop. Fold quickly and then fold slowly. The problem is with these corners. Anytime you have a corner in the graph, that means your rate changed almost instantly. But what does that mean for a rocket? Let's say that this line represents the rocket going 78 miles per hour. Well, what does that section mean? That portion where it stopped? Well, that's 0 miles per hour. So with this corner, we're showing that it was going 78 miles per hour and then in an instant dropped to 0 miles per hour. That's like crashing into a brick wall. So that corner there really doesn't make any sense for what this rocket did, because it didn't just come to a stop in the air. It slowly came to a stop as its fuel burned out. So the way this is more going to look is we're going to rise up quickly, but then it's going to start to tail off as it comes to a stop at the peak. And then it's going to begin falling, and it's going to fall faster and faster and faster as gravity really grabs onto it. But then the parachute is going to come out. Now, here we can think, is this parachute going to cause a gradual change in its speed or a very rapid change in its speed? Well, a parachute, in my experience, is going to cause a fairly quick change to that speed. And that's why I am going to have a bit of a corner right there, because that parachute, the moment it caught the air, it caused a very quick change in the speed of this rocket, and it kind of maintains that speed as it continues to fall closer to the Earth. All right, so this has been some suggestions about graphing, drawing your own sketches, and describing and interpreting the graphs that you see. I hope this is helpful. Have fun.